It's okay. Look at here. But when we are sending this traffic from the PC1 to PC2, the hub doesn't send forward the traffic directly to PC2. The hub should flood the traffic to all other ports except the incoming port. Look at here. As you can see, the hub repeating. Now the PC2 should accept the traffic, but PC3 and PC4 are dropping the traffic, and this is not a good practice, you know it. Okay, again the PC2 now is answering, the hub again should repeat it. Okay, here again we have the drop of traffic, and this is accepted. This is the inefficient or inefficiency of the hub. Now let me to show you the behavior of the switch in the same scenario. I'm going to remove this device and let me to add one switch. The type of switch, the for example switch model, is not important at all, because this is a fundamental behavior of the switch. This is one switch, and we can add this switch to our PCs. Okay, and that's it. And then for example to the next PC, and then to the next PC, and finally to the next PC. That's it. Okay, this is our scenario with the same IP addressing. Again, let me to send one traffic to the 192.168.1.2. We have response. Now we can again check or verify the status of the packets in the simulation mode. Look at here. I'm going to send traffic to the computer 2. This traffic now is receiving in PC in this switch. Now look at here. The switch only should forward the frame only to destination. Look at here. It's okay. And when the switch to PC2 is answering, okay, the traffic should go only to the PC1. This is the efficiency of the switch. Because of that, we will use the switch in our networks, and it's so important to knowing about the detail of the for example switch and hub, the differences of the switch and hub, why we don't use switch in modern networks, why we need to use the hub. Okay, now you know the answer. But let me to give you one important another notation about the hub networks, or maybe switch networks. You know that when we are using the hub, okay, here we are using the hub, if two computers are sending traffic in one time, we will have collision. This means that both of traffic should be dropped. But the question is that how one system can understand that other system now is sending traffic, and after that, for example, that system should wait. For example, assume that now the C1 is sending traffic, okay? If the C1 is sending traffic, the question is that when the C2, okay, when the C2 wants to send traffic, how the C2 can understand that this is a good time for sending or this is not a good time for sending its traffic, okay? We have a mechanism, we call it CSMA CD. Let me to talk about that. This is a old mechanism, but we should know about it. CSMA CD, okay? What is the CSMA CD? This is the abbreviation of the carrier, okay, sense, multiple, access, then collision detection. Okay, collision detection. You know that collision is a bad phenomenon, and we don't want to experience the collision. Carrier sense, multiple access, collision detection. We have this mechanism in Ethernet. We are using this mechanism in the Ethernet. For example, here we have the CSMA CD in the NIC or network interface card of the C2, and also we are using the same mechanism in the, for example, C4, C3, and C1. But what is the function of the CSMA CD? How CSMA CD can help us to for reaching to less collision? Okay, it's one important question. Let me to talk about the function of the CSMA CD. As you can see here, we have carrier sense multiple access. This means that when we are using in a multiple access networks, this is a multiple access networks, computer 1, computer 2, computer 3, and computer 4 are connecting to one networks, and because we can experience collision between these devices, this means that we are working in one collision domain. This is the collision domain. When you are using hubs, your networks is one collision domain. Why? Because computer 1, computer 2, computer 3, and computer 4 can collide with each other, okay, can experience collision with each other. This means that they are residing in one collision domain. For example, assume that I and you and our friends are, for example, staying in one room. If I and you simultaneously starting to talk, okay, our talking will collide, and because of that we are residing in one collision domain. Okay, but if I reside in one room and you are residing in another room, okay, if I talk, my conversation, my words does not collide with your word in another room. Because of that, we are staying in two collision domain. When you are using the hubs, when we have the possibility of the collision between these systems, we are residing in one collision domain. This is so important. Maybe in some exams or some interviews you encounter with the question about the collision domain. Okay, when you are using hubs, we have only one collision domain. Here in one collision domain, we need the CSMA CD rule. Okay, how? Let me to talk about this. When the C2 wants to sense the traffic first, because it know about the CSMA CD rule, first it should hear the link, the line. Okay, when the C2 finds that in line we have signal, the C2 should not send the traffic. It should wait. Why? Because the C2 can understand that if I send the traffic, okay, the traffic or the data will collide with the data now is available on the link. Because of that, with carrier sense multiple access rule, okay, the C2 should wait for a time that the line will be empty. Okay, in that time the C2 can start the sending. For example, assume now in this time the C1 is sending traffic, and this traffic now is repeated by hop. C2, C4, C3 now can understand that they are experiencing traffic on the link, on the, for example, its interfaces. Because of that, the C2 should wait. After some second, the sending of traffic from the for example, C1 is finishing. Okay, after that the C2 can send the traffic. Because of that, when the traffic of C2 is sending, the hub again should repeat the traffic. Other computers now are detecting this traffic, and because they are using also the carrier sense multiple access rule, they shouldn't advertise, they shouldn't send the traffic. This is the first rule of the carrier sense multiple access. Okay, but we can experience one interesting phenomena. Okay, look at here. When you are waiting for a time for sending your data, and after for example finding that the line is clear, you can send your data. But assume that another system exactly in that time is sending the traffic. For example, exactly the time that you are sending, the C4 also sending traffic. For example, let me to show you. This is the traffic from the C4. Okay, from the M4, the MAC address of the computer 4 to the MAC address of computer 1, for example. Okay, when you start the sending of traffic, the computer 4 also is starting the sending the traffic, and you know that here now we have collision, and this is possible. When you are waiting to find the, for example, good time for sending your data, maybe another system also is waiting for finding a good time. Okay, empty line. Because of that, it is possible in one collision domain that also although you are using the carrier sense multiple access rules, but maybe in the same time that you are starting to send, another system is starting to send the traffic, and after that you will experience the collision. This means that, for example, C2 now is sending traffic. After that, in the same time C4 is starting to send traffic. C2 can understand now the collision is occurred. Why? Because the sending traffic and the receiving traffic is not same. Okay, this means that we have another traffic on the link. You know that when the C2 sending the traffic, it can hear the line. Okay, and after it find that another traffic now is available on the line, it can understand that the collision is occurred. Okay, also the computer 4, after sending, it can compare the receiving data with the sending data, and then it can find that here we have another traffic. This means that we are experiencing a collision. Also, after C2 and C4 detecting the collision, they should inform other system about the collision, because the C1 and C3 don't know about the collision. Okay, the C2 and C4 have one reference. The C2 has the reference of its packet, and it can compare the received packet with the receive frame with each frame. If these two frames are not same, the C2 can understand that we have another frame in the line. Because of that, we have collision. Also C4. But the C3 and C1 don't know about the collision because they are receiving only these frames. Okay, because of that, we have some mechanism in the CSMA CD for informing another system about the collision. We call that mechanism jam signal. Okay, maybe some of this information is beyond the scope of this course, but let me to say that with jam signal, this is a spatial signal, the C2 and C4 can inform other system that now one collision is occurring in the line. This means that please remove the information you received before. Okay, when the C2 and C4 understanding that they are receiving another data, different data than the data they advertised, they should send the jam signal for other systems to other system understand that here we have collision. After that, the traffic that will for example is sent again should be sent. The mechanism is that these systems that detecting the for example collision should wait with for a random time. For example, assume the C2 start a down counter from 1 second, okay, to a lower value millisecond and then to 0. This is down counter. And also in C4 starting from 2 second, 2 second, 1 second, because this random timer is selecting independently in the C2 and C4. They are using in most cases different value. Because of that, for example, after 1 second, again the C2 can sense the line. If the traffic is not available, the C2 can send the traffic. This is the for example CSMA CD rule. With CSMA CD we can reduce the for example the numbers, the count of the collision, but the collision again can occurring. Okay, if you have more systems in one collision domain, the probability of the collision should increase. Okay, and if you have less numbers of the PC in one collision domain, the possibility of the collision is reducing. Okay, but when you are using switch, you don't experience the collision. You know that with switch, in each for example situation, we don't experience the collision. Let me to give you some example. Maybe this is interesting for you. Look at here we have a switch, and you know that when the switch receiving the traffic, it can forward traffic directly to the destination. Okay, for example, we are sending, let me write here, we are sending traffic from the PC5, okay, to the PC8, as you can see. And in the same time, okay, in the same time, we are sending traffic from PC6 to the PC7, okay, as I mentioned before. Now, this traffic is receiving from the PC6 to the PC7, okay, the destination MAC is the MAC 7. Switch intelligently can forward the traffic to the C7. Because of that, we don't have any collision. Okay, this means that in this example we don't experience the collision. But let me to give you another example. For example, in the next example we can say we are sending traffic from computer 5 to computer 8, and in the same time from the computer 8 to the computer 5. Again, we don't have collision. Look at here, when you are sending traffic from computer 5 to computer 8, and in the same time, for example, from the computer 8 to the computer 5, because we are using different pins for sending and receiving, again we don't have collision. Look at here, the source MAC is MAC 8 now, and the destination MAC is the MAC 5 in the